My name's Nick. I started Nick's Electronics Repair about a decade ago, and since then have fixed over 26,000 devices. In today's video, we're going to be showing how to fix a Yamaha receiver with a no audio fault. For the diagnostics, I have a heat gun and I have freeze spray. Obviously, I've removed the cover so we can expose our HDMI board, and I'm going to start by heating up this chip right over here.
And I'm just going to go over.
And now our audio is working. Now I'm going to freeze it, and our audio stopped working. I'm going to heat it up again. And our audio is working again. We'll freeze one more time. And our audio stopped working again. So this confirms that the processor right over here that we heated and cooled is at fault and will need to be replaced. For the removal process of this chip, because it does have a ground pad in the center of the chip, we are going to use a preheater. So the preheater, what it's going to do is slowly heat up the bottom of the circuit board as well as that ground pad. And once it's reached a high temperature, we're going to go ahead and then desolder it with our hot air from the top. So I'm going to turn on the preheater. It is currently set to about 300 Fahrenheit, and we're gonna let it sit for about 3 to 5 minutes. So while it's preheating, I'm actually gonna add a little bit of flux on all of the legs. And I'm also gonna add some solder to all of the pins. Now the reason I'm adding extra solder is because I'm gonna use that as a visual indicator to let me know when the solder is molten that the chip is ready to be lifted off of the board. So when the solder is all molten and liquid, it is nice and shiny, and when it is solid, it is a little bit more dull. All right, it's been about 4 minutes. We're gonna go ahead and start adding some extra heat from the top. And my solder is still looking dull. Oh, there's a few spots that it is definitely now getting shiny. Let's go ahead and give it a try. Nope. Okay. And, oh. Sheesh. There we go. So I definitely had a hard time picking that up correctly the first try there, and I fear I may have knocked a couple components off. So we're gonna have to do a visual inspection to make sure I didn't accidentally knock off any components on the surrounding area of the chip. All right, and while the board is hot, let me go ahead and remove all that extra solder. So this is that center pad in question, and as you can tell, there's already some delamination happening. So the fact that it's delaminating so easily tells me there was a lot of heat stress in that area. All right, and then we did add a lot of flux, so we're going to want to remove all of that. And I'm just using a Q-tip and isopropyl alcohol. I did do a very in-depth look, and I noticed two things. Number one is we do have a capacitor right there, and it is knocked sideways. So it is still present, and it still has one side soldered down, but the other one is loose. So we're gonna have to adjust that one. And I also noticed we have a missing resistor right over here. All right, so first let's go ahead and take care of this capacitor. So it's actually not attached on that other side. I'm just gonna end up using some hot air actually to reflow that capacitor. There we go. And as for this missing resistor, we'll go ahead and deal with that after the chip is installed. Let's add our solder paste for that center ground pad. I want to show you a very up-close shot of those solder balls. Solder paste is essentially just really, really small solder balls that are just embedded in flux, and that's how they stick together. This is what we have. So we have our solder paste on the center pad. We're going to put our brand new replacement chip. So I want to line it up as closely as I can. and that is to make sure that our center pad makes contact with that solder paste. All right, so I'm going to use the magnifier real quick to align the chip. I'm gonna add just a little bit of solder on one of the corner pins. This way the chip is locked in. And now I can make small adjustments. Now that looks a little bit better. So I'm gonna lock in this side now. Oh, that just moved. So that looks lined up more or less exactly how I want it. We can go ahead and start soldering it down using our hot air. Now at this moment, we don't have any solder on any of the pins or the legs of the chip, so we'll do that afterwards. First, I do wanna make sure that our ground pad is properly soldered down. All right, and I think that should be enough. I don't wanna overheat the chip and break it. And while it's cooling down, I did notice that we have some bent pins. So I'm gonna push that one back just a little bit. We'll do the same with this one. That was a little much. There we go. Let's check the rest of the chip. That looks good, that looks good. This one's a little bit bent inward. That's better. Let's bend this one back as well. There we go. So we're gonna do the rest of the soldering with the microscope, and we're gonna start by adding some flux to all of our pins here. And I'm just putting a big blob of solder, and I'm gonna drag it along, covering all the pins and pads. So I am putting a little bit of downward pressure on the chip as I'm soldering, because it seems like the chip is actually slightly elevated, and so the pins are not actually making contact with the pads. All right, so that's better. Okay, and that last little blob, we'll go ahead and remove that with the desolder wick. Okay, I think that's good. Now to verify my work and to make sure that all of the pins are properly soldered, I'm gonna use this to rake the pins, essentially putting pressure on every single one of them individually, and if any of the pins move, then it means I did not solder it down properly. Okay, and it looks like none of them moved, so I did solder them down properly. However, I think I have a bridge right here, and I do. So what I mean is I have a little bit of solder in between the second and third to last pins here, and that solder is bridging the pins to one another, creating a short. Looks like I just got it. All right, now that I've touched up the solder, let's recheck, make sure we still have good contact, and we do. I'm gonna do the remainder of the 3 sides off screen since it's gonna take a while, and then we'll reconvene for final testing. So our last step is replacing that missing resistor, and I was able to identify it as a 33 ohm resistor. This is the smallest one I have. It is a little bit too big, so most likely what I'm gonna do is solder it down like this. Now for this job, I did switch to a smaller tip. That is very ugly looking, so let's add some flux. That is much better. We'll just clean that off real quick. All right, and that is going to complete our repairs on this HDMI board. Let's go ahead and insert it back into the receiver and live test. I've reinstalled the HDMI board back into our receiver. It is on, it is playing a video, and obviously we're getting audio. To prove to you that the chip is cold, I have my thermal camera, and you'll see it says negative 28 degrees. So I actually did already freeze our chip. Let me turn it back up a little bit. I'm just soldering one of the legs. And we are at negative 25 degrees Celsius. So this does confirm we have a successful repair. If you have an HDMI board for a Yamaha receiver that you'd like to send in for us to fix, we do offer flat rate services, which of course come with 1-year warranties, and I'll have links to our website for that in the video description down below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.